In this module, we shift from what the onboarding system does to how well it must do it. We'll walk through security, privacy, auditability, availability, scalability, interoperability, and maintainability, and turn them into a clear quality baseline for the target architecture. So far, you've put three big pieces in place. First, you understand why EIDAS 2.0 exists, who the main actors are, and how the EUDI wallet journey works end-to-end. Second, you walked through a concrete business onboarding scenario and mapped the user journey. Third, you translated that journey into functional requirements for users, relying parties, verifiers, KYC engines, and operations. Now we'll layer quality expectations on top of that so they can feed directly into the architecture inputs. Functional requirements describe what the system must do. Quality attributes describe how well it must do it. The user can present ID from the EUDI wallet is only the starting point. In regulated onboarding, architecture is really driven by questions like, is that presentation verified, auditable, privacy-preserving, and resilient to replay? Those qualities shape components, security controls, hosting choices, and integrations. If they're vague or missing, compliance and security gaps only show up very late in the project. Non-functional requirements only become useful when they're expressed as concrete scenarios. Think in terms of a stimulus, the environment where it happens, how the system should respond, and what we'll measure. Translate good performance into numbers like 99.9% uptime, under 2-second response, or recovery within an hour. Then assign an owner, tie each NFR to a specific architecture decision and test, and refine it over time using threat modeling, regulatory changes, and real operational data. Security requirements for wallet-based KYC form a layered system. At the base, you protect confidentiality of attributes, verification results, and consent with strong encryption and tight data access. Next, you preserve integrity by signing wallet presentations, hardening APIs, and keeping tamper-evident audit logs. On top, you enforce strong authentication and authorization for all portals and consoles. Finally, you design for threats, detect replay, token substitution, fraudulent wallets, API abuse, and insider misuse before they impact onboarding. When a wallet sends attributes, the verifier's job is to actively challenge them, not just accept them. First, it confirms the presentation is genuine. Signatures are valid, the issuer is recognized in a trust registry, and the response actually matches the verifier's request. Next, it checks status and assurance. The credential isn't expired or revoked and fits the required trust framework. Finally, it blocks replay, binds everything to this session, and records results in a way that supports later audits. Privacy by design should act as a permanent filter in your architecture. Every data flow has to pass necessary, proportionate, purpose-bound. For wallet-based KYC, that means only requesting attributes you truly need and using selective disclosure. So you see, for example, over 18 instead of a full birth date. Keep identity, business, logs, and analytics data in separate stores. Then bake privacy controls into UX and APIs so users can understand, manage, and revoke data use at any time. Consent creates a trail your architecture must remember. For every agreement, you capture who asked, what attributes were requested, why they're needed, which policy version applied, and the user's explicit action. Those consents must then be tied to specific, allowed processes, not reused freely. You minimize data by requesting only what each process truly needs. Finally, you manage the lifecycle, honoring withdrawal, enforcing retention limits, and reliably deleting or anonymizing data. Auditability means you can replay the entire onboarding story and prove every step was justified. You need a clear chain: what the user presented, how they consented, which checks ran, what the results were, and why the final KYC decision was made. Each artifact gets an owner, a defined retention period, and a sensitivity level. All of it must stay linked to the case, tamper-evident, and easy to search during investigations. Your logging strategy should feel like 4 distinct streams with different jobs. Technical logs help engineers debug systems. Security logs focus on threats, access, and abnormal behavior. Business event logs record what happened for the customer. Onboarding started, documents received, decisions made. Compliance evidence is a curated subset, protected like legal records. Across all of them, enforce immutability, integrity checks, tight access control, encryption, and minimal personal data using tokens or hashes instead of full attributes. Availability and resilience requirements answer one practical question. How often can this onboarding service be down before the business gets hurt? You define uptime targets for user flows and internal tools, plan for failures in every external dependency, set recovery time and data loss limits, and design graceful degradation so customers can still move forward when parts of the system fail. Scalability isn't just about surviving Black Friday levels of traffic. It's about doing that while keeping onboarding smooth and predictable. Start by quantifying normal and peak volumes, concurrent users, and acceptable decision latency. Then break the journey into asynchronous steps: KYC and AML checks, data validation, evidence packaging, even manual review. Wrap these with robust retries, backoff, and idempotency, and constantly watch queue depth, latency, errors, and abandonment so you can react before customers feel pain. Interoperability is about making your verifier work smoothly with many wallets, issuers, and credential types without custom integrations every time. Design around open standards like OIDC4VP, clear presentation formats, and explicit trust metadata. Specify exactly which request and response modes wallets must support, and which signing algorithms are allowed. Assume multiple credential formats: JWTT, JSON-LLD, mobile documents. Then protect yourself with conformance tests, versioned APIs, and a repeatable interoperability test suite. When you rely on external KYC, AML, fraud, or sanctions providers, your real product is the integration layer. That layer should hide vendor quirks behind stable APIs, strong schema validation, and predictable versioning, all exercised in dedicated test environments before production. Policy needs to be configuration, not code. Attributes, thresholds, routing, and retention. Finally, you track engineering health. How frequently you can deploy, how often changes break, how fast you recover, and how much is automatically tested. Non-functional requirements turn KYC onboarding into an architecture problem, not just a feature list. They define how identity data is protected, audited, available, scalable, and interoperable in production. In the next topic, we'll combine these quality requirements with goals, constraints, assumptions, and risks to drive the target solution architecture.